Alright, so let's talk about algebra. This is a bit of a mathematic meme, so we'll get stuck in. Alright, so algebra is essentially the study of mathematical symbols and this whole group of rules that we use to manipulate these symbols. So in high school, it's mainly about learning the different techniques that we'll use to manipulate and solve equations, like linear simultaneous equations, decomposing into partial fractions, that type of thing. So it's really about learning the different techniques and kind of the basis of the techniques to really help you manipulate at the base level. In higher level algebra, there's more in-depth study of things that, we look into so in high school, we kind of just assume that those techniques are a thing, right? It's kind of like learning the formulas for things versus having to prove the formulas. So if you want to do it in university or if you're interested in that type of thing, you might be asked to prove things that, we kind of took for granted. Okay, so let's talk about simultaneous equations first. So simultaneous equations are essentially, like the name suggests, when we have two equations simultaneously. And it's essentially just when we have like two or more equations, and we're often trying to solve for multiple variables. Generally, the number of simultaneous equations has to correlate to the number of unknowns. So you can have more equations than variables, but the only thing you need to be careful about in that type of case is that if you have more equations than variables, so you do all your solving, do all your magic, and then when you sub it into the last equation that you haven't used yet, you just need to be really careful that it works, because sometimes the goal of the question is actually for you to prove that something isn't working instead of it is working. So we have simultaneous equations is a thing that's throughout methods, and you would have been doing kind of pre-VCE as well. So hopefully the ideas and the concepts behind it sound quite familiar to what you think. But let's go through a couple of these questions. So these are linear simultaneous equations. So these are our linear simultaneous equations, and you'll see on your calculator as well, you're able to choose between like linear simultaneous equations versus your kind of more complicated simultaneous equations. So, or anything non-linear essentially. Okay, so the general methods that we can talk about substitution or elimination. So maybe let's talk about just doing both as a bit of an intro to simultaneous equations, and a bit of a reminder about what's really going on. So let's talk about substitution first. So in substitution, what you want to do is rearrange one of the variables in terms of another variable, and then you can kind of substitute it in after that. So let's rearrange this. So x is the subject. We'll get that 2x will equal to 3 minus 3y. So therefore x will equal to 3 minus 3y over 2. Okay, and then we substitute, like the name suggests, into the next equation. So we'll get that this is 5 times 3 minus 3y over 2 plus 4y will equal to 11, right? So we'll get 15 over 2 minus 15y over 2 plus 8y over 2 will be equal to 11. So if we kind of look into that, we'll get that this is 15 over 2 minus 7y over 2 will equal to 11, which means that 15 over 2 minus 22 over 2 will equal to 7y over 2. So we'll get this is negative 7, right, will equal to 7y. So y will equal to negative 1. And then when we substitute that back into there, so we'll get this is 3 plus 3, so that's 6, so x will equal to 3. Cool. Let's talk about the elimination method. So elimination, you are aiming to get rid of one of the variables, and you change the whole equations and kind of minus the equations as a whole. So what we can do is we can times the first one. So if we name this one 1 and this one 2, we can times the first one by 5 and then minus away from the second one times by 2. So what we'll get is this times by 5 will give us 10x plus 15y will equal to 15. and that will be minus this times by 2. So that will give us 10x plus 8y will equal to 22. So once again, we'll get that 7y will equal to negative 7, and y will equal to negative 1. So therefore, if we substitute that back into here, into one of the equations, we'll get 2x minus 3 will equal to 3. So x will equal to 3. Or you can even substitute into the bottom equation as well, because you'll get 15x will equal to negative 5x minus 4 will equal to 15, so you get x equals to 3 as well. Okay, let's try this with a little bit more complicated. So in this case, it's not really going to be possible for us to use the elimination method because we have different, the x squared, y squared versus the x by itself. It has different powers on it, so we're not really going to be able to cancel out the terms unless we try and square and try and do something funky. So the easiest thing to do for this one, it would just be to substitute. And it already has it in the form of y equals to x plus 4, so that's really beneficial for us because we can just go x plus 4 all squared will equal to 26. So we'll get that this is x squared plus 8x plus 16 will equal to 26. So we'll get that this is 2x squared plus 8x minus 10 will equal to 0. So therefore we'll get that x squared plus 4x minus 5 will equal to 0. So we can get an equation of x plus 5, x minus 1, and that equals to 0. So we'll get that x equals to negative 5 or x equals to 1. And we can check, is there any restrictions on what we can take? Nope, not really. So if we try and sub this into our y, this would mean that y equals to negative 1 or y would equal to 5 here. So you can kind of see how it switches in terms of the positions, and it kind of gives you the same result in the end. And that's just because of this one, the x squared plus y squared relationships. That's why it kind of looks like the numbers are switching positions there, with the positivity and negativity of them. Cool. Awesome. Alright. Okay. So we want to solve for s in terms of a only, and we've got these two wonderful equations that we're trying to deal with, right? So we have as equals to s plus h, and then ah equals to a plus h, right? So the first thing that we want to do is replace. So we want to replace the h so that h is gone, right? That's our first goal, to get rid of it. So what we can actually see here is that if we took away this, right? Because we want only as, right? We don't want ah. So we need to replace the h's away. So if we say h is therefore equal to as minus s, we'll be able to substitute that back into here. So we'll get that this is going to be a times as minus s equals to a plus as minus s, right? So we'll get a squared s minus as equals to a plus as minus s. Okay, so then we want to get all the s's on one side, so we can kind of divide through by that. So if we try to divide all of that onto one side, we'll get this is a squared s minus 2as plus s equals to a. So if we divide that by s, we'll get a squared minus 2a plus 1 equals to a. And then we'll get s will equal to a over a squared minus 2a plus 1, right? Or otherwise known as just a over a plus 1. Sorry, a minus 1 squared. Minus 1 squared. Cool. Awesome. And then you can kind of just make sure that's true. So, or you can even just try and find out what h is, I guess. But from our working out, that's essentially what we're doing. So we did a bit of a substitution for this one, because we moved the s across and then we subbed it in, so we got a times as minus s, and then plus a plus as minus s. And then once you get that, you can kind of rearrange from there onwards to really get the equation that you're looking for. And yes, that is it.